All right, so let's go ahead and execute this. The first thing we're going to do is we need to have a radius value. So this is a variable, and it's going to be a float value, right? So we'll call this radius, float radius. And we'll set it equal to, let's say, 15, right? Okay, and then we can go ahead and do our setup. The setup structure. And here we'll define the size, background, and our fill again, right? So size is going to be, let's make it bigger this time. Let's double the width, 800 by 400. Background will be white, so 255. And let's say that the fill will be 0, 120, 255. Right? And that's going to be the fill for all the objects that we have. All right, then in the draw structure, we'll set that up as we have before. Open the curlies, close them down here. All right, and we said that we wanted to refresh the background of the display window. So we'll go ahead and do that just by restating that the background should be white, so it will refresh. All right, and now we'll set up a loop as we did before. So for int I, and I is the convention for a counter. That's the one you typically start with. So I equal to 0, I less than or equal to the width of our display window, and I is going to increment not by 1, but by the radius. So we'll say plus equals radius. Close our parentheses, open our curly brackets, and down here, the end of the for loop is going to be after the draw ellipse. So I'll auto format, Control T, and now we have everything indented inside of here. So now we need to do the Y direction. So we need another loop. So for int j equal to 0, j less than or equal to, not width, but height, and j plus equal to radius again. Close parentheses, open curly brackets, and then down here, again, close curly brackets. And I'll hit Control T to see if we have any, if our indentation works successfully. It does. All right, so what this is doing is stepping through the display window an increment of the value we set as the radius. So it will be 0, then 15, then 30. So basically, these are going to help us to find the positions of our circles in the display window, right? So the only thing we need to do now is to find out what the size is going to be, right? And store it in a variable, right? So float size. Actually, that's a bad name to use because it also is a keyword up here. So we'll say or let's say, how about current rad, or for radius, current rad equals the distance, dist, between two coordinates, which are mouse x, mouse y, and the position of our circle, which is at ij. So it's the distance between this coordinate and this coordinate position inside the display window. And then we'll say that the distance is also going to be divided by the radius, right? So if we were to run this, right, nothing's going to happen, but if I was here, every position within my grid is going to look to my position of the mouse, and I need to divide it by the radius so that that distance, which may be something like 300 units, would actually be relative to the radius that I've set here, right? So it's not overly sized, let's say, all right, or oversized. Okay, so the last step is that all we need to do is say that the ellipse should be drawn at position ij, and we'll use current rad to define the size in x and size in y. All right, and let's see how that looks. Okay, so this looks similar to what we had in the example when we ran it before, but we also have the stroke or the edges of all of our circle are also being drawn. Right? So this is interesting because it shows us exactly what's happening. When we're far away from our mouse, we have circles that are overlapping, so it looks like a solid color. And as we get closer to the mouse, the circles are getting a lot smaller, right? And we can see the background beyond. So let's add in one more detail to the properties of how things are drawn. Let's go up to the setup and say that we don't want a stroke on any of our shapes. So we'll say no stroke. So we run that. Now we have graphically a little bit nicer visualization of our grid, right? Because it just looks solid where our mouse is not. Right, so that's looking good. The last thing that we could do is if we wanted to change the fall off or the damping for how far away our circles scale to being completely fill in the frame, we would just create a value to multiply this this by before we actually use it for the ellipse. So if you wanted to do that, you could include another variable called call it damp, and this is if we set it between 0 and 1, it can be a simple value like 55% or 75%, 0.75. And then we'll just use this to multiply by our expression. So if we say 75, right, that's going to be or 0.75, that's going to extend how far away the effect is occurring, right? So if I went up and said 0.5, right, it's going to be even farther, right? So that's a way to calibrate the behavior of the scaling circles. All right, great. So if you have any questions, let's go ahead and drop them in the question window. We'll take a couple minutes to review them. This will be the last exercise we go over today in the webinar. And while you're doing that, I will add in some more pseudocode based on the things that we added in at the end, right? So this was a damping value for the distance-based behavior. We added in the no stroke, which is included in all this. And we just adjusted our expression, so that looks good. I'll save this. So I'm just opening up a couple of the example files to give you a hint of what we will be going over in the next webinar. So if we're comfortable with developing simple behaviors, right, that wherein the rule that's defining the behavior is always consistent, we can start to use those behaviors or define slightly more complex behaviors, things that may look like a bouncing ball, right, or if we can develop the behavior of one bouncing ball, we might be able to start to look at how we create multiple bouncing balls, right? If you look at the difference between the two bits of code that we've shared with you, you can see that it's pretty easy. It's relatively straightforward in terms of how you create one bouncing ball. But for each new ball that you want to create, you're going to have new variables to define all of the properties of that ball. So that's really where we get into object-oriented programming and where it becomes really powerful. So we can create our own objects. In this case, we'll call it a ball that is defining a class. And each one of these is a ball, but each has its own set of properties, right? And we can relate those properties to each other. So one ball understands where another ball is or where its environment is to get some more interesting and complex results in terms of the graphical output. All right. So there weren't any questions about the last exercise. So you guys are champs. Done really well.